Hello, welcome back to the channel. In this video, I'm going to discuss AS Physics Paper 1, which is related to October-November 2023, Paper 1-2. So it is not just mere discussion that I'm going to do in this video, but also full plus detailed discussions together with some tips that I'm going to share in this video, which could let you identify the answer just by looking at the question right away to save your time in answering paper 1. So please stay tuned. First question, what is the best estimate of wavelength of green light? So if you have already memorized the answer, you could actually identify the answer right away. But if you have yet to memorize the answer, okay, just like me, I only memorized the wavelength of the blue light, which is the shortest wavelength, and the wavelength of red light, which is the longest wavelength, because green light is within that region. So the wavelength of blue light is between 300 nanometer to 400 nanometer, whereas the wavelength of red light is between 600 nanometer to 800 nanometer. So the answer is obviously B. Question number 2. In an electric circuit, an emitter reads 2 microampere. In a second circuit, the emitter rates 1 milliampere. How many times larger is the current in the second circuit compared with the current in the first circuit? Now, this question is to test your understanding on prefixes. So look at the first emitter, which rates micro. Micro represents 10 to the power of -6. Whereas second circuit, second emitter reads 1 milliampere. Milli represents 10 to the power of -3. So if you want to compare how many times larger, you take a larger value divided by the smaller value. So the larger value is 1 times 10 to the power -3 ampere divided by a smaller value, which is 2 times 10 to the power -6 ampere. So you get 500 times larger. That's the answer. Question number 3, a set of repeated measurements is made of a fixed quantity. An average of these measurements is calculated. What is the effect of averaging on random error and systematic error? Now, this question is to test your understanding on the random error as well as the systematic error. Now, think it easy. I always like to think it easy. Random error, random, the word says it all. Random means coming from all directions. You don't really know where is the specific cause of that error. Whereas systematic error, look at the word system. Normally, think it easier, system can be related to apparatus that we have in the lab. So when you are averaging, that also means that you take different values and find the average. I would say that because random error is the error that coming from all directions, you don't really know a specific cause to that error. You take many readings and find the average, random error could be reduced. But systematic error, let me give you a simple example. You have a micrometer and that micrometer has a 0 error, and you so happen that you forgot to minus the 0 error from the micrometer. So don't you think that all your readings will be added with the 0 error? Right? So when you take many readings and you find the average and the 0 error is still there. So you are not reducing systematic error by taking many readings and find the average. So let us look at the answer. Random error and systematic error are both reduced. No, only random error can be reduced by averaging. B, random error and systematic error are both unaffected. This is not true as well because random error will be reduced. C, random error is reduced. This is true, but systematic error is unaffected. This is also true. And I just want to check on D, random error is unaffected. This is not true. Systematic error is reduced. That is also not true. That is why the answer is C. Question number 4. A boat is crossing a river in which the water is moving at a speed of 4 meters per second from left to right. In still water, the speed of the boat is 6 meters per second. The boat is directed at an angle theta to a line perpendicular to the river banks. The resultant velocity v of the boat is in a direction perpendicular to the river banks. What are the values of theta and v? Now, when you have three vectors, right? So the easiest way to solve this question is by drawing a vector triangle. So I would draw my vector triangle. The first vector that I drew was velocity of the water, which is 4 meters per second from left to right. And then when you draw a vector triangle, always remember tip to tail rule. Now, what do I mean by tip to tail rule? That means the tip of the first vector that you drew must be connected to the tail of the second vector. So the second vector that I draw here is the velocity of the boat, which is 6 meters per second. So the tip of 4 meters per second must be connected to the tail of 6 meters per second. And the resultant vector, you just need to draw from the tail of the first vector connected to the tip of the second vector. That is how you draw your resultant. So could you see that this is 90 degrees? And after that, I label my theta. Why do I label my theta there? Looks weird, right? Now let me explain. When you look at the figure, theta, look at your theta. Theta is between 6 meters per second and the resultant velocity. So this is the resultant velocity. This is 6 meters per second. So that is why I locate my theta in that position. Then after that, since this is 90 degrees, don't you think that you can use the Pythagorean theorem to find your resultant vector? So to find my resultant velocity, it is 6 squared minus 4 squared. It is because 6 is a hypotenuse. So I get 4.47 as my resultant velocity. And theta, I am using tangent theta, which is opposite over adjacent. So I get 41.8. So the answer is A. I round it off to 42. Question number 5. A student walks at a constant speed for a distance of 50 meters in a time of 40 seconds. And the student rests for a time of 10 seconds and then walks back to the starting point at a constant speed in a time of 30 seconds. What is the distance time graph for the motion of the students? Now, when they ask you to plot a distance time graph for the students, you have to bear in mind that distance is a scalar quantity. There's no direction needed for you to consider. So remember, distance is a scalar quantity. Direction is never being counted. So A, okay, so between 50 meter in a time of 40 seconds. So I just going to check on A first. 50 meter in a time of 40 seconds. So it seems like this is resting time, because resting time, the gradient of the graph must be equal to 0. So that means the student is not walking because there's no speed here. So for your information, I need to find the speed, the gradient of the graph, and compare with the information that the question gave. So the student is walking, so there must be a speed, so there must be a gradient. So A is incorrect. What about B here at 40 seconds? So this line is horizontal. It is supposed to be a straight line graph from 0 second to 40 second because the student is walking for 50 meter in 40 seconds. So B is also wrong. Let us look at C. From 0 to 40, this is a straight line at 50 meter. Yes, this is correct. And for D, yes, this is also correct. And then after that, the student rests for 10 seconds. So 40 to 50 is the resting time. This is correct as well. 40 to 50 seconds, this is resting time. Yes, this is correct. And then after that, the student walks back to the starting point at a constant speed. Okay, so student walks back to the starting point at a constant speed. You got to find the gradient. The constant speed in time of 30 seconds. So I just want to check my speed at this point first. Okay, I just need to find the gradient. So this is 50, 50. This is 80 and 0. So let me find my speed here. So 50 minus 0, y2 minus y1 over 50 minus 80. I get a negative value here. But what about D here? This is 50, 50. This is 80 and 100. So 100 minus 50 over 80 minus 50. I get a positive value. Okay, so when I get a positive value here, this is 50 over 30. So 50 divide 30, I get 1.67. And this one, 50 divide negative 30. So I get negative 1.67. Since the speed must be constant speed. So I am not allowed to get a negative number. So D is my answer. Because this is a scalar quantity. So question number 6, the time taken for an object to fall from rest. So when I see the word from rest, I always put u equals to 0 because the initial velocity must be equal to 0 through a certain distance on Mars is Tm. The time taken for the same object to fall from rest through the same distance on Earth is Te. The acceleration of free fall on Mars is 3.71 meter per second square. Assume that air resistance is negligible on both Earth and Mars. What is the ratio Tm to Te? Now, first of all, this is the equation. One of the kinematics equation that I use is S equal ut plus half gt squared. But I can't forget about ut because the object starts from rest. So the whole thing here is equal to 0. Then on Mars, I calculate S equal to half gm squared. Gm is the gravitational acceleration of Mars. Tm squared is the time taken. So I just sub in the values there. I put as equation 1. And on Earth, I do the same thing. And I have my equation 2. So after that, I just equate because the distance, because they fall. The object fall with the same distance. So I just equate. Equation 1 is equal to equation 2. So I just cancel whatever that I can do here. And then put Tm over Te. So since Tm square over Te square, so you want to find the ratio of Tm over Te only. So you just need to square root. And the answer that I got was C, 1.63. Number 7, which statement about mass is correct? A, mass has magnitude and direction. This is definitely wrong because mass is a scalar quantity. B, mass resists changes in motion. This is also true. Larger the mass, larger the inertia. Now, if you want to understand more on mass and inertia and weight at the same time, you could actually have a look at one of my YouTube video here. Please check on that. I did discuss the differences between mass, weight, and as well as inertia. C, the greater the mass, the greater the acceleration. No, acceleration depends on force. D, the mass of an object depends on its location. No, that is related to weight. Now, the answer is B. Question number 8. A snooker ball has a mass of 200 grams. It hits the cushion of a snooker table and rebounds along its original path. The ball arrives at the cushion with a speed of 40 meters per second and then leaves it with a speed of 7 meters per second. The ball and the cushion are in contact for a time of 0.6 seconds. What is the average force exerted on the ball by the cushion? Now, to solve this type of question, you need to sketch a diagram at least. So I always sketch a diagram because I can see it clearer. I can put in all the information needed because there's a lot of information given in one question here. So when I put in all the information, I could see it very clearly. And then after that, recall your Newton's second law. Whenever they ask about average force, resultant force, always recall your Newton's second law. So if you want to know more about Newton's law of motion, there are 3 laws altogether. You can refer to one of my shorts on the YouTube as well. So hope you enjoyed that video. And so now I just write it down. Newton's second law, F is equal to mv minus mu over t. So you just sub in whatever information that is needed here. And for your information as well, V here represents velocity. So you need to put positive to one direction and negative to the other direction. Since I put positive to the final velocity, initial velocity must take a negative value. So I just sub it in, and at the end of the time, I get my value. I get my answer here, which is 7 Newton. Question number 9. A ball falls from rest through air. This is air resistant, definitely, and eventually reaches a constant velocity that is related to terminal velocity, if you remember. And for this fall, the forces X and Y vary with time as shown. What could be forces X and Y? Now, when you look at this graph here, you could see that this is a graph of terminal velocity. Terminal velocity is the maximum velocity achieved by an object. In this case, terminal velocity is the velocity, maximum velocity achieved by the ball when the weight of the ball is being offset by air resistance. So the force here must be air resistant, because air resistant that forces the graph to be in this way, because the air resistance will increase to a maximum value. It cannot increase more than the weight of the ball. So it will reach a static here. And what about force Y here? You could see that acceleration, since the air resistance increases, resultant force acting on the ball will decrease and eventually equal to zero. This is where terminal velocity is reached. So force Y must be resultant force. Therefore, the answer is A. Question number 10. An object X of mass 0.3 kilogram is traveling in a straight line at a constant velocity of 3 meters per second on a horizontal frictionless surface. Object X collides with a stationary object Y of mass 0.5 kilogram. After the collision, X moves with a velocity of 2 meters per second at an angle of 60 degrees to its direction before the collision. Object Y, on the other hand, moves in a velocity v at an angle of 41 degrees to the direction of X before the collision, as shown. What is the value of v? Now, the good thing is they show us a diagram, so save our time in sketching the diagram. So if you want to make your, you want to solve this question in a fastest way, I would suggest you to resolve it vertically. You can also resolve it horizontally, but resolve vertically. Why do I choose resolve vertically? It is because before the collision, X is moving in horizontal direction. I just want to consider before the collision, total momentum before the collision is equal to zero. That's all. That is why I want to resolve it vertically. And after that, okay, I apply the principle of conservation of momentum. Total momentum before must be equal to the total momentum after the collision. So remember, momentum is a vector quantity. Okay, so I put before is equal to zero because I cannot resolve it vertically. And after that collision, okay, because momentum is a vector quantity, so you have to bear in mind this y, okay, since it is moving in this direction, so I resolve it vertically, I can resolve it into straight, okay, upwards. So I consider upwards as positive direction, downwards as negative direction. So negative to x, positive to y. So this is what I got here. And then I equate it. Then my v is equal to 1.58 meter per second. So the answer is C. Question number 11, a uniform rigid beam of length 3.2 meter is pivoted at its center. Two children sit at the opposite ends of the beam as shown. One child has a mass of 24 kilogram and the other child has a mass of 36 kilogram. The heavier child causes one end of the beam to permanently rest on the ground so that the beam makes an angle of 20 degrees to the horizontal ground. What is the moment of the weight of the 24 kilogram child about the pivot? Now you got to understand the principle of moment here. In this case, anti-clockwise moment. How do we calculate the moment? It is actually the product of force and perpendicular distance from the pivot. So step-by-step solution here. First of all, you recall moment, which is force times perpendicular distance from the pivot. And after that, since the weight of the children are vertically downwards, you have to resolve that inclined length to horizontal direction to calculate the moment because they have to be perpendicular direction. So this is the length of the inclined plane that is given here, which is 3.2 meter, and the angle is being given. I need to resolve into horizontal direction. That's all. So when I resolve into horizontal direction, I do cos 20, and my length in horizontal direction is 3.01 meter. And then after that, moment of 24 kilogram child. So I answer the question after that. It is equal to the weight of the child because that is force times the perpendicular distance from the pivot. So why do I divide 2? Look at this. Look at this. 24 kilogram Um, the heavier child causes one of the beam. Let me see. Because the length of the uniform rigid beam, the length is 3.2 meter, pivoted at the center. So the pivot is placed at the center of the whole length of the beam. That is why the 24 kilogram child is half of the length of the whole beam. The distance, I mean the perpendicular distance. So that is why I take 3.01 divided by 2. And I get 354 nanometer. So I round it off to 350 nanometer. Newton meter, sorry. Newton meter is the correct unit. Nano is just a prefix. So question number 12. Two parts of a sailing boat are the mast and the boom. The mast is a vertical rigid beam and the boom is a horizontal rigid beam. One end of the boom is attached to the mast by a pivot. The other end of the boom is connected to the mast by a rope as shown. The rope is at an angle of 40 degrees to the horizontal and exerts a tension force T on the boom. The weight of the boom is 200 Newton. The mass of the boom is uniformly distributed along its length. The boom is in equilibrium. So in equilibrium, that means the anti-clockwise moment must be equal to the clockwise moment. So what is the magnitude of T now? So I am also giving you the step-by-step solution here. First of all, resolve T into vertical direction first. So this is T cos 50, which is vertical direction. So why do I get T cos 50 here? Because here, this is my T. This is the T vertical. Since this is 90 degrees, so this is 50 degrees. So this is T cos 50 to get my vertical direction. And then after that, okay, just use the principle of moment, which is total clockwise moment is equal to the total anti-clockwise moment. And then T vertical to the pivot, identify your pivot first, is anti-clockwise. And the weight, which is 200 Newton towards the pivot, this is clockwise moment. So the whole length of the boom is, I just put L because no value is being given here. So I just put L, which is 200, okay, from 200 because it is pivoted at the center. So this is L over 2. So when you solve it, the T that you're supposed to get is 156 Newton. I round it off to 160 Newton. So the answer is B. Question number 13. Full fat milk is made up of fat-free milk mixed with fat. A volume of 1 times 10 to the power of -3 meter cube of full fat milk has a mass of 1.035 kilogram. It contains 4% fat by volume. A lot of fat, a lot of full fat here. The density of fat-free milk is 1.04 times 10 to the power of 3 kilogram per meter cube. What is the density of the fat? Oh, there's a lot of full fat, fat-free. Wow, it makes me confused, really. So I took a longer time to solve this because I have confused, okay? I confused full fat, free fat, fat, right? So I use the total volume first. I find my total volume of the fat-free milk, which is, I submit whatever information that I've been given here. So my volume of fat-free milk is 9.6 times 10 to the power -4 meter cube. And then from there, I could find my mass of the fat-free milk, which is density of the fat-free milk times the volume of the fat-free milk. And I got 0.9984 kilogram. It doesn't matter how many significant figures that I put here because that's not the final answer yet. And then the total mass is given, which is 1.035. So from there, I could find the mass of the fat because I need the mass of the fat to find the density of the fat. So the mass of the fat is 0.0366 kilogram. That's a lot, right? So the density of the fat in this case is the mass of the fat divided by the volume of the fat. So I got 915 kilogram per meter cube, which is also B. Question number 14, which expression for pressure is correct? Pressure is defined as force over area. So A is the correct answer. Question number 15. A wooden cylinder floats partially submerged in a bath of water. A force F is applied to the cylinder until it is just fully submerged. Which statement is incorrect, not correct? So you have to be extra careful with the word. A, some of the water gains gravitational potential energy. That is also true because some of the water being pushed, right, by this wooden cylinder. So they have a certain distance being pushed down, right? So that is true. B, the cylinder loses gravitational potential energy. That is also true because when it is going deeper, because the height, when it is being pushed inwards, the height is actually decreasing. So that is also true. C, work is done by force. Yes, because the force is doing work to push the wooden cylinder downwards. This is true. D, work is done by the upthrust on the cylinder. That is incorrect. So D is the answer. Question number 16. A system has a useful power output of 4 watt and a wasted power of 16 watt. What is the efficiency of the system? Now, how do you calculate efficiency? It is the useful output power divided by the input power times 100%. So first of all, I need to find useful output power is being given. So I need to find the input power. Input power is the useful output power plus the wasted power, which is 20 watt in this case. Now to find the efficiency, I just sub into the equation. Useful output power is 4 watt over input power is 20 times 100%. So you get 20% as your efficiency. Number 17, parachutist is falling towards the ground at a constant speed v. The rate at which she is losing gravitational potential energy is r. The acceleration of the free fall is g. What is the mass of the parachute? So since they mentioned that the parachutist is falling at a constant speed, and they did mention the rate at which she is losing gravitational potential energy. That means delta GPE per time. This is just like energy per unit time that gives rise to power. That is why I replace with power. Power is equal to force times the constant velocity. And then after that, because rate of gravitational potential energy, right, is R. So I put R because rate of gravitational potential energy is actually power. So I replace with R. F, because it is falling, parachutist is falling. So I replace F with the weight, mg, v. And then M, I make M as the subject, R over gv. So B is the answer. Number 18, a copper wire of diameter 1.6 mm is stretched with its limit of proportionality by a tensile force of 430 Newton. The Young modulus of the copper is 130 gigapascal. What is the strain in the wire? Recall, Young modulus is equal to stress over strain. Since the force is being given and the diameter of the wire is being given, so I put, okay, resolve my stress to force over area. Sub into the equation. I have force over area times 1 over strain. And you have to bear in mind that since this is a copper wire, the surface area of the copper wire is A equal to pi r squared. It's a circle. So there is no apparatus in the lab that we can use to measure the radius. Therefore, we relate to diameter. Diameter over 2 is equal to radius. So when you sub it in, you get pi d squared over 4. And Young modulus, okay, sub in the area. So you get F over 1 over 4 pi d squared times 1 over strain here. Then you sub in whatever information that is given. 130 giga is 10 to the power of 9. This question tested you on prefixes at the same time. So force is 430, 1 over 4 pi d is given m, milli is 10 to the power negative 3. But remember to square it times 1 over strain. And at the end of the time, make strain as a subject, and you should be able to get 1.6 times 10 to the power negative 3, which is C. Question number 19. Compressive forces are applied normally to the end faces of a cylinder of initial length L. The cylinder is compressed by the forces so that its length decreases to 0.6 L. After the compressive forces are removed, the cylinder's length increases to 0.8 L. What describes the deformation of the cylinder when its length was 0.6 L? So when you compress it, the length will decrease to 0.6 L, right? And then after the compressive forces are removed, this cylinder's length increases to 0.8 L. That means when the length that means when you remove your compressive force, the atoms inside the cylinder trying to restore back to the original position. That is why the length increases. So in this case, both elastic and plastic are involved because at the end of the time, it can only restore. Yeah, it try elastically restore back to the original length. But original length is L. It can only restore to 0.8 L and it has permanent deformation, which is also called plastic deformation. Question number 20, when sound travels through air, the air particles vibrate. A graph of displacement against time for a single air particle is shown. Which graph shows how the kinetic energy of the air particle varies with time? Now, I want to give you step-by-step solution for this question here. You have to plot the velocity time graph. How do you plot the velocity time graph? Is that you have to relate. Remember here, this is a displacement time graph. To plot the velocity time graph, recall your straight line equation, right? Straight line graph. Velocity time graph can be calculated from the gradient of displacement time graph. But I want to do it in a simpler manner, teach you the simplest, fastest method in getting the answer. So remember at maximum displacement, V is always equal to 0 because when you draw a tangent here, it will always give you 0 gradient. And then after that, this is my velocity time graph that I have plotted roughly like that. So kinetic energy is equal to half mv squared. In this case, because this is about one air particle, so the mass of the air particle is constant. So you can say that kinetic energy is directly proportional to the speed square or the velocity you square it. Right? So therefore, when you square it, all the negative value becomes positive. So that is why you get this graph right here. So the answer is definitely D. Number 21, a wave travels on the surface of water. P, Q, R, and S are 4 particles of water on the surface. The diagram shows the positions of the particles at one instant. Direction of travel of the wave is from left to right. Which 2 particles are about to move outwards? Now, when you see this type of question, don't just guess. You can get the answer quite accurately. So all you need to do is look at the direction of wave travel. To the right, they have already mentioned very clearly. Now, the easiest way to do it, step-by-step solution. I just copy the wave that is given here first. And then after that, remember, you know that the wave is traveling from left to right. So the wave profile must be shifted from left to right. So you just shift the peak to right a bit. I just roughly sketch, so maybe my peaks will be quite different because I just sketch it. I'm so sorry about that. But you have to imagine that this crest shifted to the right. This trough will be shifted to the right. Is that okay? And then after that, don't just stop at one wave profile that you drew. Sketch another one. Could you see that? It seems like my wave profile is moving to the right. Can you see that? Now, after that, look at the direction. Compare the original position of the wave with the new wave profile that I drew. So P is going downwards, you see? Q, compared to the green wave that I drew because the wave profile has already shifted. So Q is moving outwards, R is moving downward, and S is moving outward. So you could identify the direction very accurately. So therefore, the answer, which 2 particles are about to move outwards? Look at your wave again. Outwards is your Q and your S. See that? So the answer is quite obvious. D is the answer. Question number 22. A loudspeaker emits sound of frequency Fs. A loudspeaker is attached to a car that moves with increasing speed directly towards the stationary observer. Which statement describes the frequency of the sound heard by the observer? Now, this is Doppler effect, don't you think so? When the loudspeaker is coming towards the stationary observer, don't you think that the frequency is increasing? Just imagine that the police car with the siren on. Oh, that's ambulance. I'm so sorry. Ambulance. Yeah. Wow, it has a greater pitch. So the frequency is greater. Right? So when the ambulance with the siren on just pass you, okay, and you are stationary, right? So what happened? Okay, after that, right? And did they say pass? Okay, they just say that a loudspeaker emits sound of frequency fs. The loudspeaker is attached to the car that move with increasing speed directly towards you. You're just coming towards. So the frequency is greater and it is increasing. So A is the answer. And question number 33, which statement about the electromagnetic waves in vacuum is correct? Now, let me see. Amplitude is inversely proportional to velocity. This is not true. Amply because, okay, B frequency is inversely proportional to the wavelength. So now all the electromagnetic wave travel with the speed of light. I am going to use the V equal to F lambda, but this V I'm going to change to C, which means speed of light. F lambda. So speed of light is constant. F is inversely proportional to wavelength. This is correct. So B is the answer. Now, question number 24. A vertically polarized electromagnetic wave of intensity I naught is incident normally on a polarizing filter. Transmission axis of the filter is at an angle of 30 degrees to the vertical. Transmitted wave from the first filter is then incident normally on the second polarizing filter. Transmission of axis of this filter is at an angle of 90 degrees to the vertical. What is the intensity of the wave after passing through the second filter? So I am also going to give you step-by-step solution here. Recall this equation. Do you recall this? I equal to I naught cos square theta. This is Moore's law. So theta is being given as 30. So I just find my transmitted wave first from the first filter. So I is equal to 0.75 I naught. And then for passing through the second filter, so it is related to this I. So I2 is equal to I cos square 60 because it has been rotated 60, right? So, and then after that, okay, just sub in 0.75 I naught times 0.25. Cos square 60 is 0.25. And you get 0.188 I naught. Oh, 60 is not being given. How do I get 60 here? Is because I take 90 minus 30, right? So that is why I have 60 degrees here. So the answer here is 0.188 I naught, or you can round it off to 0.19 I naught. That's the answer. And question number 25, which statement concerning a stationary wave is correct? A, all particles between two adjacent nodes oscillate in phase. Oh, I need to draw this out, right? Okay, I will draw this out. So this is my fixed position. Okay, this is my wave. The first wave first. Okay, I just draw more. And this is my, to show that these two waves superimpose to give you stationary wave. And bear in mind, this is called node, 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 and node. Just look at the nodes, right? Between two adjacent nodes. So I just look at this one loop. So if you like the blue wave, just focus on the blue wave only. So since I like blue wave, I just focus on blue wave. So all the particles on blue waves are oscillating upwards in one loop. So when they are oscillating in the same direction, we say that they are in phase. This is true. Let us look at B. B, the amplitude of a stationary wave is equal to the amplitude of one of the waves creating it. No, that is not true. It is equal to the amplitudes of the two waves. C, the wavelength of the stationary wave is equal to the separation between two adjacent nodes. Now, one wavelength is this. So that is called one wavelength. Is it related to separation between two adjacent nodes? No, it is separation between three nodes here. So this is incorrect as well. D, there is no displacement of the particle at antinode. At antinode, the particle oscillate with maximum amplitude. So this is not true. A is the answer. Number 26, stationary sound wave can be formed in the air column of pipes. One type of pipe is closed at one end and open at the other end. Another type of pipe is open at both ends. Which pipe can form a stationary sound wave with the lowest frequency? So, okay, I do it one by one. So for wave open at two ends, you have to bear in mind the two open ends must be antinodes. So the first lowest frequency means fundamental frequency. So, okay, for fundamental frequency for A, this is related to 1/2 lambda. So I make a fundamental frequency as a subject, B/4L. So I compare with B, tube closed at one end, the closed end must be a node. So this is 1/4 lambda is equal to 2L, lambda is equal to 8L. So therefore I get fundamental frequency is equal to V/8L. C, tube open at both ends, is 1/2 lambda can be formed here, is equal to L, make lambda as a subject, and F is equal to V/lambda. So V/2L, and D, tube closed at one end, remember the closed end must be node. So F fundamental frequency is V/4L. Now you have to compare which one give you the smallest value here. 1/4, 1/8, 1/2, or 1/4. So the answer is quite obvious, right? It is 1/8. So B is the answer. Number 27, water waves in a ripple tank are made to pass through a small gap as shown. Which diagram shows the waves after they have passed through the gap? When the waves pass through the gap, right? This situation is called diffraction, spreading of wave. This B is wrong. C is also wrong, right? So what happened here? A is the correct answer because this gap is very small. And when I check roughly, so the size of the gap is roughly equal to the size of the wavelength. Therefore, maximum diffraction will occur. A is the answer. Question 28. Light of a single wavelength is incident normally on a double slit. The slit separation can be varied. A screen is placed a fixed distance away from the double slit. The screen and double slit are parallel. A pattern of bright interference fringes is observed on the screen. Which graph best shows the variation of a separation x of the bright interference fringes with the slit separation A? First of all, you have to recall the equation of the interference. Lambda is equal to ax over t. So it is about x and A. A is inversely proportional to x. So A is the answer. Question 29, a diffraction grating is used to measure the wavelength of light. The spacing of the slits in the grating is 1.15 times 10 to the power negative 6 meter. Angle between the first order diffraction maxima is 60 degrees as shown. What's the wavelength of the light? Remember, when you recall, you use that equation of the diffraction grating. D sine theta m is equal to m lambda. M represent number of order. So this sine theta must be measured from the horizontal reference line. So 60 degrees, you have to split to half, which is 30 degrees only, yeah? So 1.5 times 10 to the power negative 6 sine 30. So since this is the first order, just put 1. M is equal to 1. So lambda is 575 nanometer. C is the answer. Question 30. What could not be used to create an electric field? Of course, neutron cannot be used. Why? Because neutron is neutral. Remember that? Alpha is positive 2e, beta is negative E if you talk about electrons, or positive E. So proton is positive E. So since all of these are charged particles, only neutron is free of charge. So therefore C is the answer. Number 31, what is the definition of potential difference? Can you see they ask you about definition, right? Across a component. So the definition of potential difference is work done per unit charge. So the energy transfer per unit charge, that is the correct definition. Work is equivalent to energy. Energy is ability to do work, remember? 32, the resistance of a filament lamp increases as the current in it increases. What is the reason for this? The charge of each charge carrier increases. That is only valid to semiconductor diode. B, the potential difference across filament decreases. Did they mention that? No, they did not mention that. So don't ever assume that to be correct. C, the power dissipated by the filament decreases. Did they state that? No, they didn't state that. Don't make assumption again. D, the temperature of the filament increases. That is also true. Yeah, so D is the answer. So if you want to experience this in a real life, you get a light bulb, you just connect to a battery, and after a while, maybe a few seconds, just touch the light bulb, and then please beware, right? When you touch the light bulb, you can feel that there's a little bit of warmness here. Why? Because the temperature increases. 33. A battery of electron multiforce EMF 12 volt and negligible internal resistance is connected to a fixed resistor of resistance 40 ohm and thermistor of resistance R as shown. Initially, the temperature of the thermistor is 15 degrees Celsius and the current in the circuit is 0.1 ampere. The temperature of the thermistor then changes, which causes the current to increase to 0.12 ampere. How does the temperature of the thermistor change, and what is the RT, resistance of the thermistor at the new temperature? Now for this question, a bit of IQ involved here, but I'm going to give you step by step, give you the solid answer for that, right? So first of all, find the PD across 40 ohm resistor, because 40 ohm, the resistor won't change. So the PD will always be constant unless you change another EMF, right? So I just recall Ohm's law, Mr. George Ohm, V equals to IR. I is given as 0.1, R is 40. So you get 4 volt here. So you find the PD across the thermistor after that at 15 degrees Celsius. So the PD, total PD, because thermistor and 40 ohm are being connected in series. So you just take 12 minus 4, that is 8 volt, right? So now when the temperature changes, they also told you that the current increases to 0.12 ampere. So you find a new PD, yeah, across that 40 ohm resistor. So new PD, okay, of the 40 ohm resistor is 0.12 times 40. But you want to find the PD across the thermistor, right? So I straight away minus, so I take 12 minus 0.12 times 40. So I get 7.2 volt. Can you see that? And after that, potential divider concept to find RT. V output over V input is equal to R output over R input. So 7.2 over 12 is equal to R thermistor over R thermistor plus 40. So I get R thermistor as 60 ohm. See that? And then use Ohm's law to compare. So use Ohm's law. V is directly proportional to R. Why? In this case, it is valid because the thermistor and the 40 ohm are being connected in series, so current will be constant. So when V decreases, V of the thermistor decreases from 8 volt decreases to 7.2 volt, the R of the thermistor will decrease. So when the R of the thermistor decreases, that means the temperature of the thermistor will increase. Therefore, the answer is A. Question number 34. A cell of electromultiforce EMF 3 volt and internal resistance 0.5 ohm is connected to a variable resistor, a voltmeter, and an ammeter as shown. The resistance of the variable resistor is varied. The reading on the ammeter I and the reading on the voltmeter V are recorded. Which graph shows how V varies with I? Now, I use the equation of EMF, which is equal to the terminal potential plus IR, the potential difference across the internal resistance. So make V as a subject because the graph, the y-axis is a V, EMF minus IR. So then you compare, y-intercept is your EMF. Can you see that? So the y-intercept must be 3 volts. So say goodbye to A, say goodbye to D. So it is between B and C. And after that, you could see that the x-axis is I, right? So the gradient of the graph must be negative R. So the gradient of the graph must be negative 0.5 ohm. So, okay, only B will give you negative 0.5 ohm. You know how I do it? Y2 minus Y1 over X2 minus X1. So 0, 3, I'll do it here. 0.5 and 0. So for B, 3 minus 0 over 0 minus 0.5. So you get negative 0.5 here. So no, you don't get negative. You get 3 divide 0.5. You get 6. I'm sorry. Okay, so I make erase here. So you have to do some calculation. Luckily, I did here. So 3 minus 0 over 0 minus 0.5. So you get 6 here. I want negative 0. Negative 6 is my answer for B. So B is wrong because I want to get negative 0.5. So I do see 0, 3, and this is 6, 0. So 3 minus 0 divides 0 minus 6. So 3 divided by negative 6. So I get exactly 0.5 here. C is the answer. Okay. Now, question number 35, three resistors R1, R2, and R3 are connected in parallel to a cell. The currents in the resistors are I1, I2, and I3. Potential difference across the resistors are V1, V2, and V3. The current in the cell is I0. The potential difference across the cell is V0 as shown. Which equation can be obtained by applying Kirchhoff's second law to the circuit? Kirchhoff's second law, say goodbye to A and B, because Kirchhoff's second law states that the total EMF is equal to the total PD. So it has to be related to EMF and PD only. So let us look at C. V0 here is equal to V1 is equal to V2 is equal to V3. This is correct because all the resistor R1, R2, and R3 are connected in parallel. So they share the same PD. So C is correct. So C is the answer. Question 36, three resistors, each of resistance R are connected in a network as shown. The total resistance between points X and Y is 8 ohm. What is the value of R here? So, since R is being connected parallel to 2R, I simplified this diagram a little bit. Okay, you can put it in this way. R, and then this is 2R because series, you just add them out. This is X, this is Y. So make our life easier, don't you think so? We simplified the circuit. So to find the total, oh, they have given us the total resistance. 1 over 8 is equal to 1 over R plus 1 over 2R. So work it out. Okay, your R should be equal to 12 ohm, which is D. 37, a potentiometer and a driver cell of EMF are used to measure the EMF of a new cell. A sliding contact at P is moved along the resistance wire QR until the reading of the galvanometer is 0. What is an essential requirement for the EMF of the new cell to be measured accurately? Let me see. Look at the choices one by one. A, the EMF of a driver cell must be less. No, it has to be more because driver cell is the main cell. This is called driver cell. It is the main circuit that drive the current through. B, the galvanometer must have a large resistance. No, we don't make sure that the galvanometer have a large resistance because galvanometer is just to let, if there is a current flow, then the galvanometer will deflect to see whether there's a current flow or not. C, the internal resistance of new cell must be 0. Who can make sure that? That is not true. D, the resistance per unit length of wire QR must be constant. This is true. That is the reason why we have to make sure that our resistance wire is as straight, as uniform as possible, right? So D is the correct answer. Question 38, the table shows the number of nucleons and the total number of particles, protons, neutrons, and electrons in neutral atoms of 4 nuclides, W, X, Y, and Z. Which 2 nuclides are isotopes of each other? So I need to calculate their number of protons and electrons. Protons and neutrons, sorry. Total number of particles here represents the total number of protons, neutrons, and electrons. So for the first one, I take 30 minus 19. 30 minus 19, I get 11. 30 minus 19, I get 11. For the second one, 31 minus 19, I get 12. Third one, 32 minus 21, I get 11. And then 31 minus 22, I get 9. So since W and Y have the same total number of particles. So all the particles balances each other. So therefore, W and Y are isotope. They have the same number of protons, neutrons, and electrons. Question 39. When a sample of radioactive isotope decays by alpha particle emission, the alpha particles emitted have a single discrete energy. When a sample of radioactive isotope decays by beta-negative particle emission, the beta-negative particles emitted have a continuous range of energies. What is this explanation for this? Let us look at A. An anti-neutrino is emitted with a beta-negative particle, but not with an alpha particle, which is true. B. An anti-neutrino is emitted when, no, with an alpha particle, never. C. The alpha particle have much more energy. That is also not true, not explanation to that. D. The beta-negative particle have much more energy. No, you have a range of energies due to the anti-neutrino, a range of energies that is being emitted here. So A is the answer. Last question here, number 40. Some particles are a combination of 3 quarks. Which combination of quarks does not result in a particle with a charge of either positive 1.6 times 10 to the power negative 19 coulomb or 0? So let us look at A, up quark, right? Positive 2 over 3, down quark negative 1 over 3 E, right? And down quark negative 1 over 3 E. So I get 2, 2, 2, I get 0 here. Okay, this is true. And then this is strain. Up is positive 2 over 3e. This is negative 1 over 3e. This is negative 1 over 3e. I get 0. This is correct because I will need 0 as well. This one C, up is positive 2 over 3e. Positive 2 over 3e. Negative 1 over 3e. So I get positive e. This is also true because positive e is related to positive 1 over 6. The charge of the one electron is 1.6 times 10 to the power negative 19. Up, 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 positive 2 over 3e, positive 2 over 3e, positive 2 over 3e. So it is positive 6 over 3e, which is positive 2e. This is wrong. D is the answer. So that is all about our discussion today. So feel free to ask me more questions. Yeah, please do comment. Yeah, down there. If you have any hesitation or any doubts, do not hesitate to pause the video to copy the solution. So if you need the solution in the PDF form, do also comment below. So thank you very much for watching, and I hope this video helps you. Bye, see you again.